What I'm going to do talking about tonight is literally the user experiences because, as you will find out, I know very little about software-defined radio. I just want to introduce you to it in the same kind of learning curve that I had in the last year when I decided to get a kit and try and make it all work. So what I'm going to start by doing, it's going to last about 20 minutes, and then I really want you to ask lots of questions because it's pointless me just being a one-way conduit boring you all to death. It's easier if you simply stop when I'm starting to use phrases which you don't follow and say, I don't understand where you're going with that one, just tell me to back up. So I must really say, once again, reiterate for this recording that this is not theory, it is pure practical experience. I may be completely wrong on many points. So let's begin with the nuts and bolts. This is a typical software-defined radio PCB card. You'll notice, if you can see from the distance where you're sitting, is there are no trim pot capacitors, there's no inductors, it's just a set of ICs, resistors, and some capacitors there. That's the heart of software-defined radio. You're reducing costs when you want to make them, because this is much easier to produce than custom things with lots of more expensive components like capacitors and inductors and so on. What you're doing is shifting the discrete components that do that work over to the software in a computer. So the job of this card is to produce something which you can plug into the computer, and the natural interface for that is the stereo input line socket on your computer. Does anyone want to have a look at this, or shall I? Oh, okay. When you begin with software-defined radio, you know you want to listen to or view something on the end on a laptop. So you've got a computer in mind usually you want to work with, and that's got an operating system on. And the operating systems are, of course, Windows, Unix versions, Linux, and Mac. So that's the first thing you need to worry about, what particular operating system you're going to use, because after that you then start working backwards with dependencies. All the way you're going to keep coming back to something like a PCB with a software-defined radio on it. Now you can go out and buy one for several £1,000s, or you can make up a kit. And typical ones you can see, the one I've got tonight is called the Exeter one, named after the magazine that produced it back in 2007. And it's known by that particular model. But there are cheaper ones which you can get. For instance, Soft Rock is a very popular one, only the size of a USB key, and it goes into the side of your computer. You can build the kit yourself, total cost about £30 or £40. It is, however, only does one waveband. So you buy a 40-meter kit, or you buy a 20-meter kit, something like that. The Electro one is about double the cost, but you get full waveband from 500 kilohertz right through to 30 megs. That's one of the virtues of you pay more, you get more. So in between here, you've got some gaps to fill. First of all, you've got to decide which one of these you're going to buy. How much money have you got? Is it current? Is the nicer stuff, the better stuff, sometimes using chips which you can't buy anymore, even though they're only 3 years old. You have to look at about 30 separate separate software-defined radio hardware boards. It's out there to look for. There's a huge choice to look for, and that will immediately then introduce you to the next problem, is which software program you're going to have to run. So I'll put in the middle here two parts: the software that has to run on the computer, and the other part is the sound card you've got in the computer. Because you produce from this a stereo signal, what looks like a stereo signal to the sound card, but is in fact known as the I&Q, or the quadrature modulated output from the particular card. And you put this into your sound card as the left and right audio inputs. The software then does all the clever work. It's taking in two signals in quadrature separated by 90 degrees and using mathematics to process them to produce the signal, the audio signal that you want. We'll come to a little bit more technical detail on that in a moment. And then, of course, you have to have this software has to operate on the sound card and the PCB. that you're actually using to do this. Now immediately you're going to say, but this is silly, because sound cards, there's probably 100 different varieties. Software packages, must be 50 or more. Where do you start with this? And that's the first thing you waste a lot of time with when you start to do software-defined radio study. And I'm talking 6 months, because if you're stuck with a favorite operating system, I personally like Unix systems, just trying to find something that's current, that's got all the right drivers, the right software support and so on, and then testing it and finding some particular part doesn't work can waste a huge amount of time. So that's, I'm afraid, no shortcuts. If you are a Windows fanatic and you've got a small computer you can already use, then you've got a great starting point. The first thing you'll find is that your sound card has got a problem with it. If you look at most laptops, you'll find the audio side of it consists of a mic in and somewhere else, usually on another socket next to it, there's a stereo line out. There's no stereo line input. There's no stereo input at all. So how on earth do you even start with this? Welcome to the next bit you're going to have to buy, which is a USB attached sound decoder. Or a typical one looks like this. Costs about £20, and it provides, this is actually known as a USB 7.1 channel 3D.
Nick,
yes?
Can I just ask you, I mean, most PCs, laptops have a sound card of sorts built in. So why can't you...
You tend not to want to have to use a whole computer, a desk computer. You tend to want to use a laptop.
Right.
I agree with you, large desk-type computers do have a nice set of stereo ins and outs and so forth on them, but you usually want to be a bit more mobile, and that's why the laptop is a lot more use. And laptops rarely, because of the very limited sight edging capability to put in more sockets on the side, tend to reduce that right down to just those 2 sockets. This is very, very useful though, because it provides for you a choice of line inputs, optical ones as well as ordinary audio ones, microphone, stereo line input, and the stereo line input gives you at least 90 dBs of signal to noise on the processing of the digital signal processing chips inside of this. And it also has full 7 audio channels output, so you can give it a really complex MPEG-4 audio chain to listen to, and then connect up 7 loudspeakers onto all the various outputs on this, should you so wish. So that's the next little thing. I'll pass it around if you like. Anyone want to have a look at it? Yeah, okay.
So they're about